In this video, we're going to understand the relationship between the graph of a function and the sign of its second derivative. It says the graph of the derivative f prime of x is given below. So this is f prime of x. On what intervals is the function f of x concave down? So we have to think about what it means to be for f of x to be concave down. So let's say I have a function that looks like this. I'm just making this up, so this does not look like our actual function here. Well, this is concave down, right? Here's an inflection point right here. This would be concave down basically this entire way till we get to this point here. So what is happening here? Well, we're concave down, and our slope is, let's see, our slope here would be positive, right? And then we have this change here where we go from positive to negative slope. And basically, we're going to be, if we think about what would happen with the first derivative, well, the first derivative would be going from positive to a negative slope. So the first derivative would be basically having a line that would be going down like this, where it would be going from positive slope to negative slope. So it'd be like getting ready to cross the x-axis, and it would cross the x-axis at this point here. So basically, we just want to look for any spots on this line, on this curve, where our f prime of x is decreasing. So that occurs from right here at x equal -6 to x equal -2. We're decreasing this whole time. So because this is decreasing the whole time on f prime of x, that means that we have this scenario, which means we're concave down. So we are concave down from -6 to -2. Now this would apply the same way if we were talking about concave up. Concave up, you would have a negative slope here to this point right here, but then you would have a positive slope afterwards. So you would have this scenario where you would be rising and going the other way. And I think that if we were looking at concave up, we would say that it's concave up from -2 all the way to infinity.